Hello, my name is Emilio Grande. I'm from Cal State Bay. I'll be presenting today multi-tracer characterization of Wildcat Creek in the Berkeley Hills. Golf courses are seen like one of the major contributors of pollutants to surface water due to the high amounts of pesticides and fungicides used to maintain turf systems. The East Bay Regional Park District rents in one of their parks, they rent an area for a golf course, the Tilden Golf Course, which is intersected by the Wildcat Creek, and they were concerned with the possible contribution of nutrients to the Wildcat Creek. We were given the task to analyze this possible contribution, for which we use isotopic tracers. So I would like to start explaining that we use radon 222 activity in water to study the interactions of surface water, groundwater. Radon 222 is a radionuclide. It has of 3.82 days half-life. It comes from the radioactive decay of uranium-238, which is very common in rocks. So since radon is a gas, it's found with higher activities in groundwater, and due atmospheric evasion, once it reaches surface water, it escapes to the atmosphere, so you find lower activities. This allows us to determine the places along the stream where we are gaining groundwater and where either neutral or losing to the groundwater. Having found the places where we have inflows of groundwater, we sample and analyze to determine the isotopic signature of the water, which is the composition of the stable isotopes of the molecule of water, delta O18 and delta deuterium. These allow us to do the hydrographic separation during the summer month. If you're familiar with the San Francisco Bay Area, we have Mediterranean kind of climate. We have very little to no precipitation during the summer, so we had only, or basically, two end members. For the one side we had groundwater feeding the stream. From the other side we had irrigation water used by the staff of the golf course to maintain the golf running. These two sources of water had very different, very peculiar high contrast in their isotopic signature. Irrigation water was very light water. It's water that is being brought to Berkeley from the Sacramento Delta. It's water that is coming from snowmelt from the Sierra Nevadas, which very light water, really high quality water. And then we have the local groundwater, which tends to be heavier. And then we have a mix. Knowing these two end members and the composition and the isotopic signature of the mix, we use delta O18, which is a conservative tracer, and we calculated the fraction of each one of the end members contributing to the stream. We calculated that as much as 94.5% of the mix is made out of base flow, so the groundwater feeding the stream during summer, and as much as 5.5% is irrigation water. Okay. Earlier this year, during the first event of the season, we had the task of prove the possible contribution of nitrates on the stream. So we took samples with an automatic sampler every an hour and a half. The blue bars represent the amount of precipitation within that interval, and the orange line in this first graph on the left is the delta O18 value of those samples, and we can see how they are influenced by the storm. They peak or they become lighter as the storm peaks. We also analyze for the different nutrients. We were interested in nitrate and phosphate. So as the storm peaks, again the blue lines, we can see this yellow line with its nitrates is also peaking. This is a log scale, by the way. We had lots of data, they back each other up, and we had to use a log scale in order to put it all together. So the yellow line is peaking, which is nitrate, so it's peaking as the event peaks. However, and very interesting, chloride, conservative chloride, is actually declining due dilution. It's tied to the purple line is conductivity, so chloride and conductivity, they just go hand by hand, and they both decrease as the storm peaks. Whether nitrates actually increases. In natural conditions, the chloride and nitrates, they should be dissolved in water, they should sort of behave the same way. They should be diluted as you are getting more event water into the stream. However, we observe an increase in the nitrate concentration, which is telling us that there is indeed some nitrate that is coming from the golf course. Also, we analyze for phosphate, which is also increasing, and it's tied with turbidity, which we also measure for all those intervals. To be even more sure of the possible contribution of nitrates and phosphates of the golf course, we took the task of analyzing upstream. So we analyzed up here in Elder Spring, and then downstream at Northbridge, pre-event and post-event. So these two bars here are pre-event, and these two are post-event. This two is the same location, and you can see Northbridge is here in the golf course. Pre-event, our concentration was around 0.5 milligrams per liter. Post-event is like 4 to 5 times higher. Phosphates also increase pre-event and post-event, but we didn't observe as much as difference as we did for nitrates. So we prove that actually the golf course is indeed contributing of nutrients to the stream. Our next steps is we keep taking data. We are trying to use delta O18 to calculate transit time distribution. We want to provide the East Bay Regional Park District scientific evidence about how long it takes the water since infiltration until it reaches back the surface, because they can use this when making decisions on when better management techniques are implemented. They will know how long they will have to wait to actually start seeing positive results. So as a summary, we use radon 222 to study interaction of surface water, groundwater. We use isotopic signature of water to do the hydrographic separation. We did mixing equation to calculate the fraction of the different members within the watershed in the water of Wildcat Creek. And also we have studied how during an event we observe an increase in nutrients due surface runoff into the stream. Thank you. I hope you had a blast as I've had presenting my poster. Thank you.